So hello guys, so in this video we will learn about functions in real life. So how do we construct functions given some situation on our daily life? Okay, so example number one we have here, if height h is a function of age denoted by a, give the function h that can represent the height of a person in age a if every year the height is added by 2 inches. So on the board we have here your solution. So first, let us identify your dependent variable as well as the constant of our function. So guys, in here we are constructing an equation or a function in equation form. Okay, so let us identify your independent variable, or can be known as your domain, or can be your input. Okay, and your dependent variable is your range, or can be your output. Okay, so understanding the situation or the problem on the board, our input or the independent variable or the domain is your age. Okay? By understanding the problem, we can say that the age or the height, the height of a person depends on his or her age. So as time or years passes, the height is increasing. Okay? So age is denoted by A, and your dependent variable or range or our output is our height, and it is denoted by H as specified on our problem. And here we should formulate or construct your resulting function. Okay? So the resulting function can be h of a equals, so we will need our constant. So the constant is 2 here. So every year the height is added by 2 inches. So that will be our constant. So every year we are adding 2 inches. So this will be our resulting function. So this is our age. This is our age in the unit of year plus 2 every year. Okay? So this is our example number 1. So if we will try to check, we will put some values of a equals 0, a equals to 1, a equals to 2. So assuming that the age is 0, or in real context we can say that this person is a newborn person. So we can say by our common sense that the height is 2 inches. Just like this one. So in this case, you can see that we input a on our function. A is equals to 0. Then input 1, as a is equal to 1, we can say that the height is 3 inches and the age of a person is 1 year. And so on. We can say that the height of a person is 4 inches when the age is 2 years. Okay? But by the way, this one is for our next lesson. So we will just focus on constructing functions and applying it on our real life situations. So this is number one. And now let us proceed to number two. Example number two, functions in real life. If distance denoted by capital D is a function of time denoted by small letter t, give the function d that can represent the distance a car travels in time t if every hour the car travels 60 kilometers. So again, for our solution, first is to identify our given. Okay, so understanding the problem or the situation on the board, our problem is all about the distance and what distance can a car cover given or dependent its traveled hour. Okay, so first let us identify again your independent variable or your domain or our input, as well as our dependent variable or our range or our output. Okay, so the independent variable here is time. Okay, so that is denoted by t. And our dependent variable or range or our output is the distance, denoted by capital D. Okay, so understanding the problem, we can say that the distance a car can travel depends on the time travel. Okay, so the greater the time is the greater the distance covered. And our constant is 60 kilometers. Okay, so to be basic, we will just put 60. Okay, then we can say that your distance d depends on your time t. So we can say that the distance is a function of time. So the resulting function will be written this way. So we have d of t, or time t, the function of d. Okay, so again, this is how we can write your function. We have d, our dependent variable, then close open parenthesis, then write your input or your domain or your independent variable. Okay, then put your constant 60 on the other side of your equation. Then, understanding the problem, we can say that in every hour the car travels 60 kilometers. So if we have 1 hour, the car can travel 60 kilometers. So the operation here is multiplication. So we can put t, or you can read it as d of t is equals to 60t. By checking or by evaluating this function, we can check that the resulting function is correct. Okay, so just identify what is the operation on the other side of your equation, and you can easily identify the operation on the other side of your equation by understanding your problem. Okay?